Dear students, hello, welcome to the Become a Good Problem Solver BGPS event organized by the GEM Foundation. This video we are going to see the solution for September 2025 problem for the senior grades from 6 to 8. So both the senior and junior grade problems this time are more creative, open-ended and coming up with a visual solution. So let's start reading the question. Raju created a balloon model using craft paper. The net model of the paper he used is shown. Calculate the area of the paper used. Can you draw a net model to make balloon using the paper dimensions 90 centimeter cross 60 centimeter? So, like we always discuss in the BGPS event, to approach a problem, there is a technique which is a kind of shared from the GEM Foundation, which is research proven, called UPA technique, which is expands to understand, plan, execute, and reflect. So when children know about how to approach a problem, they'll have the confidence to work on it, even though if it is easy, simple, or challenging and expanding their comfort zone. And this is why giving them steps or the framework to approach a problem is more important. So to find understanding and comprehending the problem is very important, which will help them come up with solutions quickly. So understanding is the key. And to understand, we always share these four steps of underlining the key terms, which is important, what is given and what is asked, and asking some guiding questions, which in this case we have already provided, which will help them understand what is a guiding question and slowly also develop the habit of building their own guiding questions, which will improve their comprehending capability and the clarity of understanding. And the third is drawing, modeling, or visualizing so that the information given is able to kind of understand better and look for any patterns or relationships or even concepts that they can use and apply it here. So let's read the guiding questions and start working on this interesting creative question. What does a net model mean? So it means a set of 2D shapes used to make a 3D shape. So for example, it is like the simple craft paper that they give with the kind of a marking that you can cut and make this kind of a balloon shape. So this 3D balloon paper model can be made just with these 2D shapes. So what they have having here is maybe having this small rectangles, because in this case this is a 3 meter cross 2 meters. So this is 4 rectangles, and 4 triangles which is of height 2 meters and base 3 meters, and 4 rectangles which is of height 4 meters and base 3 meters. So these are the 2D models that's been used to make this balloon model. Question asking is about calculating the area of the paper used, and we can actually first mark what are the shapes, that's the plan, and then you know how to find the area of a rectangle. Area of rectangle is length times breadth, and here you know what is the length. It is 3 meters cross 2 meters, so 3 cross 2 is 6 meters square or square meters for one rectangle, right? And how many such rectangles are there? Are all of them same? Yes, all of them are same, so you only then it can fit in, right, in this case. So for 4 rectangles, how do you find the area? It could be 6 times 4, which is 24 meters square. Now we have to find for the triangle, and as you might be knowing, the formula for finding the area of triangle is times base times height. So in this case, for the triangle on the top, it is 3 meters is the base. So it into 3, and height is 2 meters. So into 2. So 6 divided by 2 is 3 meters square. And how many triangles we have? 4 small triangles. And that would be 4 times 3 is 12 meters square. And what about area of the bigger triangle on the bottom? The same way, it is half times. So in this case, the base is again the same, 3 into 4, right? So 4 3s are 12 by 2 is 6. meter squared, and for 4 triangles it would be 6 times 4 is 24 meter squared. So now, in order to find the area of the entire paper used, you can just add all of them. So for rectangles, you got so the total area of the paper will be 24 squared plus 12 meter squared plus 24 meter squared, and that in turn is 48 plus 12 is 60 meter squared. So this is the total area. So this seems to be a problem till now. The next question asked is, can you draw a net model to make a balloon using the paper dimensions 90 cross 60? So I think many children were thinking that you may need to actually use a similar scaled one and apply it to 90 cross 60. Yes, that could be a very interesting one, and you can also make any kind of a balloon model that can be fit in using the 90 cross 60 centimeter. So in the solution, we are going to see that the model that we are making from 90 cross 60 is kind of a scaled model of the given dimensions here. So what you can try. So now let's have a planning of how you can come up with a scaled model. Whenever you say the word scaled, it actually will refer to you a concept of ratio, because the ratio is what actually kind of makes the shape matching with either the smaller one or making it as a bigger one. So the ratio is the concept that we have to be using. And next comes, how do I come up with the dimensions, right? So here you have some dimensions and the paper I am having is different. So now there are so many unknowns. So what do you use when you have unknowns? Yes, you're right. We'll be using algebra. So this design problem is a very interesting concept where you are applying ratio, algebra, geometry, and in a visual way, which will be very interesting and a hands-on kind of a problem. So let's go ahead and see how can I start with. So the starting is a real thing that children kind of figuring out a bit tough. So how many 2D shapes are needed and how the dimensions of the 2D shapes can be found to be made in a 90 cross 60 centimeter paper. How? Basically, in algebra, and especially in algebraic thinking, what does algebraic thinking mean? It means you should identify the unknowns, first step, and then how the like assigning the variables as again for the unknowns, and how to actually make relation unknowns and find a common kind of an understanding which will help you approach the problem. So in this case, let's start with the actual problem which is given here. Is this is 3 meters and this is 2 meters in the rectangle. So we don't know in our 60 centimeters how to do it. But what we know is this is the height and this is the height of the below triangle 2, 4 and 2. So if you can see that all of them are kind of related, and maybe I can tell that the height of the rectangle, right, I can maybe assign it as x, right, rectangle's height I can assign it as x because I don't know. And how can I relate other designs based on this dimension x? That is the main important part of algebraic thinking. So if the rectangle's height is x, what can be the height of the triangle? Height of small triangle. It is also same, right? 2 and 2. So height of small triangle is also x. And what is height of big triangle in the bottom? So 2 and 4. So if there is 2, it is 4. If there is 3, maybe it could be 6. So if there is x, yes, you are right. This has to be 2x, right? So if x is 1, then big big triangle is 2. If x is 2, then the big triangle is 4. So this is how we have made a relation of height of the big triangle, which is 2x. So now we have made some relation. This is the first part of algebraic thinking. The second part of algebraic thinking refers to frame expressions or equations based on the information given. So you have to frame expressions or equations, whatever it might be, from the problem. So what is the problem given? That the given dimensions is 90 centimeter length, the paper, and 60 centimeter on the height. So this is the paper given. So my entire height matters as height of small triangle, height of rectangle, and height of the big triangle, and that equals to 60 centimeter. So let me apply the second part of algebraic thinking, framing expressions. The height of the entire net model should be x plus 2x is the height of the entire net model, and in the given dimensions it should be equals to 60, right? So x plus 2x is 60, and so this is 4x is 60, and x is then 15 centimeters. Wow. So now we have understood that in my model, the height of the rectangle should be 15, height of the small rectangle also should be 15, and height of the big rectangle should be 30. So with this, the model that I am making is a scaled or a ratio model. Also you can call it as a similar figure of the given net model. So you understood that we have found one part of this. We know how to kind of split the height. Now coming to the length, right? So in this length, what are the things that is made? It is made of. It's simply made of 1, 2, 3, 4. So if you know that in the given model, it is 3 meters, the length is 3 meters. So how do I come up with the with reference to the x that I am talking about, right? So if the x is, so in my model, if the x is 2, how should I find the 3? And here comes the ratio, right? So in the existing one, the ratio of length is to height is 3 is to 2. And in the model that I'm going to make, I don't know what is the length, but I know what is the height, right? I know it is 50 height. So how do I find the length correspondingly? From the ratio understanding, you might be knowing that if the two ratios are to be equal, then you can write it as 3 by 2, like the top one, like length by height of the two shapes should be same. So 3 by 2 should be equal to the one that I have made, the length of my new design, by 15. So again, if you want 3 by 2 is equals to L by 15, you know that if I want to find some value, I can actually make it as a subject, right? So 15 times 3 is equals to L times 2. So you can actually multiply. I'm just taking the division to the left hand side, which becomes multiplication inverse operation. Division here, which will go to the right hand side with the inverse operation of multiplication. So 45 is equals to 2 times of L, and so I can also write it interchangeably. 2 times of L is equals to 45, and L is equals to 45 divided. So the multiplication becomes inverse operation, be 22.5. So let's check if the model is exactly fitting. So we have a rectangle which is of dimension, which is having a dimension of 15 centimeter each, and then 24.5, and then this is again 15, and the top height is 15 and the bottom height is 30. And here are 4 triangles, so we can check if the 4 triangles are having the same height. Yes, and this is 30. Okay, so in this case, let's check if the height is matching. Yeah, 30 plus 15 plus 15, yes, it is matching to 60 centimeter, and this is 22.5. So with the length, it has to be 22.5 4 times because of the rectangle now 4, and that will make up to 90 centimeters. So with this example, what we have understood is the concept that we need to try are algebra to figure out how to compare the how to come up with the dimensions and the ratio for a scaled similar figure model, and finally a geometrical aspect of how a 2D model can be used to make a 3D model of the balloon that is given here. I hope this was an interesting learning experience of combining different concepts, identifying what concepts to be applied, using the guiding questions, and coming up with a plan and then execution, and reflecting how if our model actually fits into the question that has been asked for. So thank you. And this BGPS event is a monthly event organized by GEM Foundation. Please do participate in the event and submit your solutions, which will be shared. Thank you. Stay tuned.